Hey folks, how you doing? Hopefully you're all having a great day today. I get a bunch of email, and sometimes that email is a little bit repetitive in the subject. So in that case, it makes more sense for me to make a video replying to the general audience rather than that specific email. That way, when those questions come back, I have a place to point people towards. So the subject of this video is router bits. Before we get into any details, it's important for me to disclose that I do have a marketing relationship with a company that manufactures router bits. So, knowing that, I have two things. Number one, focus not on model numbers or brands or anything like that. Focus on the geometry of the bit and understand when and why to use it. And once you've determined what type of bit you actually need, at that point, consider checking out Bits and Bits Company. Like I said, it's a small business, or like I said, I have a marketing relationship with them. They're a small business out of the Pacific Northwest. They make quality router bits. They distribute white side router bits as well, and which is another manufacturer of quality bits. But what they do that's very nice is they add an Astra coating to most all of their bits. And what that Astra coating does is, number one, it reduces friction, which therefore reduces heat buildup, which therefore prolongs the life of the bit. So you pay a little bit more for an Astra coating, but the lifespan of the bit, the quality of the bit is extended much more than, say, multiple purchases of a non-coated bit. That's my personal findings anyway. And how I developed a relationship with them is I was a fan of white side router bits, still am, they make great stuff, for many years, and have used white side router bits. And a friend of mine introduced me to this company called Bits and Bits that does an Astra coating on white side bits. And since then, I've been using both white side and Bits and Bits bits that are all Astra coated, and it's just phenomenal results. I'm going to show you some bits that I've had for a long time and have put a tremendous amount of use on them, and they're still my go-to bits because they're still producing fantastic results. So there's my little built-in bias. I really like what they're doing. The quality of their product is fantastic. I have absolutely no problem putting my brand side by side with theirs. I have a coupon code for all of you to use, and that's just a straight up coupon code for you to save money. It is not an affiliate anything. I do not have an affiliate relationship with them. I do not make any money on the volume of their sales. So whether you do or do not purchase from them, that does not really affect me. My goal is to just simply spread the word about a great company. So with that said, let's jump into the email. Jeff says, I just got my first router and remember you saying in an old video that you don't recommend getting a large set of bits at first because you won't use them all. Did you say that, or am I thinking of a different person? That was indeed me. I don't know what video it was or how long ago I said that, but I still stand behind that message. In 2009, 2008, 10, somewhere around that time, I got my first router, which was a Skill brand plunge router. I bought it from Lowe's, and I also bought a big set of router bits, a big shiny box of new toys, right? And here's what happened. I spent a decent amount of money on that router bit set, burnt up like 2 or 3 of them, and never used any of the rest of them. I bought it because of options, right? If I have all of these options, I could do anything, not realizing what I would actually do. So I think your money will be much better put to use by first figuring out what you need. And this is general advice for all tools. Don't buy what you want or what you think you want. Buy what you actually need. So determine what you need and buy a quality product that fits that need. Your money will be best spent that way, and you won't be left with a bunch of unused junk, unused stuff, right? I've made that mistake many, many times, not just with router bits. Just buy what you need rather than what you want. I think your money will go a lot further. What bits do you recommend I get for someone who just got their first router? And what is the difference between CNC bits and router bits? So I will give you a couple recommendations here in a few minutes on some very basic stuff that's universally used in almost any hobby woodworking environment. But what's the difference between CNC bits and router bits? The biggest difference is the name. Literally. I mean, all it is this particular bit, it will be used primarily in a router and a CNC machine, so we'll call it a CNC bit, but you can still use it in a router. This particular router bit will be used primarily in a router or router table, So we'll call it a router bit, but you can still use it in a CNC machine. It's a tool that spins around on a central axis to remove material. Router bits, CNC bits, they do the same thing, just what they're more tailored to. Here's a good example I've already got in my router table. So let me spin you around and I'll show you a router bit, not a CNC bit. This is a router bit in a router table. It's just a 1/4" roundover bit with a bearing. The table is beneficial because it allows you a nice wide surface area for you to reference your material off of rather than just the surface area of the bottom side of a router plate or router base. Gives you all this surface area to better control your material up against the router bit. Now you have a bearing here, so you have two surfaces that you're referencing off of the table as well as the bearing to more easily control your material as you make your cut and transfer this profile to the wood. Can you use this in a CNC machine? Yeah, let me show you. Here's that exact same router bit mounted in my CNC spindle. Now first off, bearings on CNC machines, not a good idea because you can't plunge into your material because that bearing will obviously stop you. So to use this bit in a CNC machine, which would be unadvised, you can technically use it like an upside down router table. You put your material up against the bearing and use the profile. The reason why you wouldn't want to do this is because on a router table with the bit inside the table is a physical stop to prevent the material from going too far in to the router bit, causing damage, and then the bearing is a stop in the other direction. In this case, yes, you can ride up against the bearing, but nothing's going to stop the material from being lifted up and damaging the workpiece. So technically, yes, this is an example where you could use it. Would you want to? Absolutely not. Let's flip the situation around. This is a CNC bit, specifically a 90-degree V-bit. This one has 1.5" cutting diameter at its widest point, and there's no bearing on it. Because there's no bearing, it allows you to plunge into the top of your material. You can do all kinds of stuff with this on a CNC machine. Let's go put it in the router table and see how it fares over there. Same bit in a router table, but instead of a 90-degree V-bit, we instantly call this a chamfer bit because it creates a nice chamfer on the edge. It won't be easy to create a nice chamfer on the edge without the bearing in this particular state. So in this case, you'll have to bring the fence forward and use the fence as the physical stop in the second direction to create a nice consistent edge with this style bit in the router table. So while you technically can use it, again, there's a limitation. You have to use it up against a fence. A better alternative, or this version in what would be considered a router bit, is this right here. A chamfer bit, and well, what do you know? You have a bearing on the top. Exact same results, but you can see why this is called a CNC bit and why this is called a router bit. Here's a couple bits that can be used in both routers as well as CNC machines. This is, I have to put it in a collet because it'll fall over sitting on its own, but this is a 60-degree V-bit, and of course it's a V-bit, so you could use it for V carving on a CNC machine. But it's also good for something small like a trim router to do some, handheld sign carving with a trim router. You don't need a big router to do little signs like that, and you don't necessarily want to use a big bit like the first one I showed you because that's going to most likely remove too much material. You'll probably get a little too aggressive with it, and you're more likely to get a catch or to have the whole situation be a little bit less controllable. So a smaller V-bit would technically be a CNC bit and technically be both a router bit as well. Here's one that is both a router bit and a CNC bit. So this is a 2" cutting length, 1/2" diameter, 2-flute spiral upcut bit. This is fantastic in a handheld plunge router for cutting mortises. The upcut geometry will pull the fibers away from the cutting edge, which if you're plunging into a material, it's going to eject the chips out of the mortise. Fantastic for a plunge router cutting mortises. Also very fantastic in a CNC machine for bulk removal, for profiles if you're just blowing through some easy stuff like MDF. And of course, you can still use it for all kinds of cutting operations on a CNC machine. So these two are good examples of bits that could be specified as both a CNC bit or a router bit. Inside my router table cabinet is my router bit drawer or tray. This is all my router bits for handheld use, for router table use, not CNC stuff. I have my CNC bits in another tray I'll show you. I'll just go through them all. Basically, we have some edge profiling stuff, we have some joinery stuff, and some straight cutting slash flush trimming stuff. So first off, if you were to tell me you had to pick out 2 or 3, you had to pick out your favorites or the ones you just can't live without, it would be this little roundover bit right here. And this is also available in a half shank. Let me do this. Let me just put this piece of white paper. This is a 1/8 of an inch roundover, and I didn't start using this until, I guess, about 2 years or so ago. But it's like my go-to roundover. It just breaks the edge without changing the overall shape and feel of something. So it's not going to change the aesthetics like a big 1/2 inch roundover will. Like, that'll definitely change the way a piece looks. But this will give you a nice finished roundover that destroys that sharp edge while still giving that crisp look, if that makes any sense. 1/8 of an inch roundover, huge thumbs up. My favorite roundover bit. Another one of my favorites is, well, first off, this guy gets used a lot in my shop. This is a 7/8 of an inch diameter compression flush trim bit with a bearing top and bottom. Probably not something you want to pick up right away when you first get a router, but for flush trimming, creating pattern templates, and stuff like that, it's a monster bit. I put a tremendous amount of miles on this exact bit, and it still cuts great. Absolutely great. This one's Astro coated as well. And what else do I use all the time? I use a lot of these frequently, but I think these two are probably my most used as far as the volume of use. So on this side we have all of my roundover bits, some of my dead bits over here that have dinged up and damaged the carbide on them. I still keep them back there for whatever reason, I don't know. But a 1/4 inch radius is really good to have. I've got some bigger, larger, like 3/4 inch radius bits that I don't use frequently, but it's nice to put on something that's bigger and bulkier, like a thicker tabletop. Put on the bottom side of a tabletop, just to kind of give it a little bit of a shadow. I like that. Another cool thing is I've started to see a little bit more of these type of bits. This is a, let me get this paper. This is a roundover bit that doesn't have a bearing on top. Instead, it has a bushing. Now the diameter of that bushing is less than the diameter of the shank. So this is a 1/4 inch shank bit, and I don't know off the top of my head the diameter of that bushing, but you can ride the material right up against it and still get a radius into some really tight areas. So I think this is the 1/4 inch radius, and then I used this a lot on some green type stuff. This is a 1/8 of an inch radius roundover with a 1/4 inch shank and a bushing on top. So pretty neat little bit. Wouldn't recommend it for a daily driver for all of the roundovers, but it's a kind of like specialty roundover, right? You can get into some spaces where you otherwise couldn't get into. I like these. I have a couple different sizes of these, but honestly, I haven't used this larger one often. I think I use that on my clock, actually. Something that I will recommend someone getting is a precision carbide rod. You can use this for a lot of different setup testing, test the run out on your collets and such. I've used this quite frequently. Speaking of collets, let me just jump over to that. I put this in my Porter cable routers to help me figure out where I was getting this nasty vibration. Was it in the bearing or was it in the collet? And what I found is on all of my Porter cable routers, the stock collet that comes with it, this little guy right here, these don't have that great of precision. So what I did is I upgraded them to one of these collets. I'll put a link to these as well. One of the best things that you can do to get a smoother running router is upgrade the collet. As you can see, there's a bunch of different cuts inside this collet in various different directions, top down, bottom up, or in alternating directions, I should say. And what that allows is a much more even clamping pressure as you tighten down the collet nut. One thing I will recommend also is to keep an air compressor nearby and blow out the collets when you change the bits, because I don't know if you can see it on this one, but there is a little bit of junk buildup inside the recesses, inside the cuts, And over time, that'll affect its ability to clamp down evenly. So when you change out the bit, blow out the collet, you'll get better results. What else do we have here? We got some just standard chamfer bits. Those are always handy. A couple cove bits that I don't use often at all. I purchased these a long time ago and put barely any use on them, but it's one of those things like you're making molding or whatnot, it's handy to have. Some other specialty bits like the Fit Dovetail Bit. If you're not familiar with the Fit system, they make a whole system based upon this bit geometry for clamping and whatnot. Pretty handy. Some other dovetail stuff. This is a bit, it's a flush trim bit with a scoring line on it for the connection between a cabinet side and a cabinet style for face frame cabinets. And I bought this to use on one job, and I used it on one job and haven't used it since. So there's that. It's handy to have if you make a lot of cabinets, though. Here's a bit that I've put a lot of miles on. This is a tongue and groove bit. This is a white side bit, no Astra coating. I got this a long time ago. Put a lot of use on it. The only downside with using a combination bit like this, so it's a cutting edge, it's a bearing, and a cutting edge stacked on top with a specific spacing in between, and then bolted down with this nut on top, or held in place with this nut on top. The only disadvantage of this is you have a 1/4 inch cutter, 1/4 inch gap, 1/4 inch cutter, which means you can cut both the tongue and the groove with this one bit based upon the height in the router table, but you have to cut with a 3/4 inch thick material or less. You can't really cut thicker material with this. So if you, let's just say you had a 7/8 of an inch thick material, you can't do your tongue and groove cuts in one pass per side, if you're, or per side of the joint. For example, if you're trying to cut the tongue, rather than just centering this in the height, after that, you also have to lower it all the way and cut the extra top and bottom. So it's 2 extra passes for thicker material on this bit. So for that reason, I did a bunch of cutting on a little bit thicker material for a job and got this particular set. It's 2 bits instead of 1. And as you can see here, the distance from the bottom to the top is it's over 1 inch. So you can cut tongue and groove joints, still a 1/4 inch tongue and groove, but you can cut them on thicker material with 1 pass per side of the joint. This is the tongue cutter, and this is the groove cutter. There's many different rail and style sets that you can get. This one in particular is for glass panel doors because you can put both of the let's do this. You can put both of the bearings on one of the bits and both of the slot cutters on the other bit, and it goes from cutting a slot to cutting a rabbet on the back side. So more often than not, you don't want to put glass inside of a slot. You want to put glass inside of a rabbet so you can change the glass in the event that it breaks. This is a nice little set that I picked up for a recent build that I've yet to use, so it looks all shiny and brand new still. But there's all kinds of these rail and style sets. Just find one that you like as far as the profile goes. I also have one of these gnarly looking adjustable slot bits that has several different thickness cutters that you stack in various sizes to get the exact size slot that you need. And it's kind of like a dado stack for the router table. It's a bit intimidating when I was using it. This thing is pretty crazy when you start stacking it up and using it like so. Haven't used it in quite a while. And then over here on this side, I have my flush trim bits, largest diameter 7/8 that I have, bearing top and bottom. And then I've got these, which are super handy. These are flush trim bits with a bearing, but the bearing is the same diameter as the shaft, 1/4 inch shaft. So that means you can get into some tighter spots for flush trimming. I wouldn't use this as a primary flush trim bit just because it's a smaller diameter, and I would prefer putting a larger diameter in there to have less wear and tear. It's just not as delicate, I should say, as one of these smaller ones. But when you need to get into a tight radius, well, there you go. You're not limited by the diameter of the bearing like we were previously. That sums up all of my router table bits. I have some straight cutting bits, like some bits that are specifically sized for plywood. A friend of mine gave me these CMT bits, and I'm ashamed to say that I've never used them, simply because I don't really use the router table for for rabbits or dados for plywood. I just prefer to use my dado stack and the table saw, and then some other straight cutting bits of just generic stuff that I've used over the years. Let's go check out the CNC bits. Oops. It's okay. With CNC bits, the real versatility comes from the machine and not so much from the bits. There's just a few basic bits that you can get and accomplish a tremendous amount. All of my end mills are over here, some profile and decorative stuff over here, and then all of my flattening stuff. And basically, slab flattening, this bit, decorative stuff, this bit, and anything else, end mill stuff, one of these bits. So I don't have to have all of this, but this is just stuff that I've acquired over the years, and we'll just go through them. So I have a bunch of 1/2-inch end mills. Specifically, I just showed you this one, I think. This is the 1/2-inch diameter 2-flute upcut spiral end mill, astro-coated. I use this for a lot of waste removal on stuff that I could just blow through, like MDF. Not super dense stuff like hickory, right? This is a good end mill for a longer depth of cut stuff. So I used this to cut all of the dog holes on my spoil board. So it's really good for certain applications, not the daily driver for all end mill type stuff, simply because it's a 1/2-inch diameter. I do have a lot of other 1/2-inch diameter stuff like compression bits. So compression bits, let's talk about that for a second, right? Compression means it has an upcut and a downcut spiral. So at the very tip where you're first cutting, it has an upcut spiral, and then the rest of it's a downcut spiral. That way, as you break into the top of your material, you are getting the benefit of the upcut to pull the chips up and get good chip ejection. But as you can see in this example right here, the upcut spirals are below the top surface of that paper. So what's actually cutting the top surface is the downcut. So you're pushing the fibers down into the material, and you'll get a good clean surface on the top. If you're plunging in a short, shallow distance, you're only engaging the upcut spirals, so your top fibers surrounding the cut are going to be pulled up, and therefore you'll get a lot of tear out. So that's a good example with this first bit that I just showed you. This is good for pocketing deeper stuff like a mortise, but on a shallow cut, all you're going to be doing is pulling the fibers up around the cut, and you'll get a lot of tear out. So upcut is great for waste removal, not good for a surface finish surface on top. So let's go back to that compression bit. Let's just say we plunge all the way through the material, and now we're cutting the bottom side of our material. At that point, those upcut spirals are going to be pushing the material up into the rest of the material, and you'll get a good clean bottom surface of your cut. So compression is good for both a top and bottom clean cut, so long as you go deep enough on the first pass to clear the upcut spirals on the bottom. And I'll talk about that in just a second again with the smaller diameter stuff. So 1/2-inch, I have some options, but let's see what else. Let's go down to a 1/4-inch. So probably the most used bit by far in my CNC machine is a 1/4-inch diameter downcut 2-flute spiral. So 1/4-inch diameter, we're not removing a lot of material. This is good for profiling, kind of slow for pocketing, but sometimes it's more beneficial to use a slower tool because you don't have a bit change. But this is pushing down into the material, so as you plunge in, you're going to get a nice clean top surface. And so long as your spoil board's not chewed up completely, if you go past the material into your spoil board, yes, you are going to be pushing the bottom surface of those fibers down away from the center mass of the material, but you're going to be pushing it into the spoil board, which is backed up anyway, so you shouldn't get too much tear out. So this is like the best overall bit for most all CNC machines. 1/4-inch diameter, 2-flute spiral, downcut bit. Of course, this is astro-coated. I've got a tremendous amount of miles on it, and I don't know how much gunk is going to show up on there, but there's not much. These bits last so long. So down cut. Let's go back to compression, something that is pretty darn cool. Do I have an older one? I think all I have is their newer ones. With compression bits, most often you'll see that the compression on bottom, the upcut spirals on bottom, are about the same length as the diameter of the bit. So if you have a 1/4 inch compression bit, you'll typically want to take a 1/4 inch depth of cut for the first pass to get the benefit of that compression. However, a lot of smaller CNC machines can't handle a 1/4 inch depth of cut, which is fine. You're better off just using a down cut spiral. Well, Bits and Bits came out with a shallow upcut compression, right? So the upcut part at the bottom is less than the diameter bit of the bit. I don't know the exact number off the top of my head, but you can take a much more shallow pass and still get the benefits of compression. Hopefully that made sense. So those are handy in certain situations. Well, here's a bit that I used to use a lot until I got those compressions, and that is it's a 2-flute spiral upcut, but the spirals are really shallow. So you still get the benefit of a upcut chip ejection, but you don't get the aggressive nature of the sharper upcuts. So you get a lot less tear out on the top surface compared to a regular upcut. What else do we have? We have some T-slot bits, or keyhole slots, I should say, keyhole slot bits. I had a nice white side one and broke it from going too fast. So this is my backup. I have a few of the backups, and my backups have become my priority ones because I don't use them enough to justify getting another one. So there's that. Got a couple of those. I have a few single flute spirals that I primarily use for acrylic. So single flute spirals, I get really good results cutting acrylic with these. And it's just it's an upcut bit, but as you can see, it only has one flute. And the benefit with that is you don't have a lot of rubbing from running at a too low of a chip load and causing heat buildup, which melts acrylic. You don't want to melt the acrylic as you're cutting it. So chip load, right? I just mentioned that for the first time. Chip load is the optimum size chip being cut out at a time. If this is spinning so fast that as it travels along, you're not getting an actual cut, what you end up getting is called rubbing, and rubbing produces heat. Rubbing produces friction, which causes heat, and you're gonna dull the bit much faster. So you want to have an optimal size chip being ejected during the cut. So that's chip load. And with acrylic, that's especially important because if you don't have a good enough chip load, then you will melt the acrylic. So single flute spirals, I've only used them for acrylic ever. I have a few of these tapered V-Bits, tapered spirals, whatever they're called, for 3D cutting, but I barely have ever done any 3D cutting. So these are like tapered ball nose, I think that's what they're called, tapered ball nose. I've only done a handful of 3D carving, so I barely ever use these. But if you have a CNC machine, it gives you the option. My second most used bits are V-Bits. Specifically, my second most used bit is this amazing bit right here. It's the same bit I showed you earlier in the comparison. This is a Whiteside 1508 that is astro-coated. And as you can see, I need to clean it. But that being said, I have put a ridiculous amount of miles on this bit. This bit is a couple years old, still cuts the same today as it did the day I got it. I promise you that. This is what I use for aggressive cutting. Actually, I use it for all my V-carving cutting, but basically I can use this for aggressive cutting in solid hardwoods. So I'll play on the screen solid cutting of ash. I believe this is, it's either ash or sycamore, whichever example I'm showing you. But ash is a nice dense hardwood, and this takes a real wide bite. It's just a beast of a bit, and it's got a lot of miles on it, so I can speak for its longevity, and it's well worth the price in my opinion. I like it so much that I've got a backup ready to go, unused, because I know if I break that bit, it's going to make me cry. If I run into something metal with that bit and damage the carbide, it's going to make me cry. Definitely have a backup for it. I have some other various V-bits, just other size 90-degree V-bits. That was a bad example. I don't know why I just showed you the exact same one. 60, that's what I was looking for. I was looking for 60. So you have a different angle of the V to change the look, how deep it cuts in the CNC cutting. This is a 60-degree bit. And I also have some pencil point 30-degree bits. These are good for if you need a shallow cut, but you still need that tight detail. Well, you can use this. And what else we have that we use a lot? Slab flattening, right? I've used an Amana bit, I've used an old bigger Whiteside bit, and now my go-to best performing bit by far is this monster. Now you need a decent spindle to push this thing. It's a 2.5-inch diameter carbide insert bit. It is a SB, oh, what is it? I used to know this. SB25-2 flattening bit. And this thing, I just released a video testing this out for the first time. It is my definite new go-to slab flattening bit. Works really, really well. And because it's carbide insert, it's a little bit more money up front, but anything carbide insert is a little bit more up front. Your cost savings is in longevity. Not only do the carbide inserts last longer, these are Astra coated, but they have many edges that you can rotate them, 4 edges that you can rotate around to get a fresh cutting edge, and really, really good quality stuff. Very happy to add that to the arsenal. The rest of the bits are, duplicates and, just generic stuff. I've got some dovetail bits that I use on the vertical table. Extra carbide inserts. I do have some forming bits. Like, for example, this is actually a roundover bit. Needlepoint roundover that you can do some decorative stuff with. Barely ever use them, though. Here's one. The diamond drag bit. These are really cool for etching into glass. So if you have a CNC machine, these are fun to pick up. You can etch into glass with a router bit. You don't run the spindle. You just put this down at a certain pressure into the glass and let it run and engrave it. It's pretty darn cool. Engraving glass is fascinating. There's one final recommendation that I'll make as I close this video, and that is to clean your cutting edges. Router bits, table saw blades, bandsaw blades, keep them clean and they will be cutting better much longer. It doesn't matter what brand, if there's a coating on it, if there's not a coating on it, keep them clean and your results will be better longer. I have never, ever sent off a table saw blade to be sharpened. I've never sharpened any of my table saw blades. Use them all the time, keep them clean, and they'll do a really, really good job for a really long time. There's a lot of products that you can get. I've used the CMT stuff for a long, long, long time. Good results. I've used the Rockler kit for a few times until I spilled it when I moved to this shop. Good results with it. So just keep your bits clean, and you will thank yourself for putting in that little bit of maintenance time in doing so. That's all I have for this video. Again, I do have a coupon code for Bits and Bits if you are interested in using it. I don't make any commission on their sales, like I said. Use the coupon code, save yourself a little bit of money. Check out Bits and Bits if you haven't already done so. If you have any other questions, leave them in the comments and I'll try to get to them. So you guys take care, have a great day, and I'll talk to you in the next video.